Hello, this is Raj Patel, and today we're going to be talking about a pH and pOH and how we calculate it using several formulas. And so, here is a picture of a pH scale. And notice on the pH scale, we have pH from 0 to 14. So just know that pH is from 0 to 14. And notice how we have 7 in the middle, which is neutral, and water is neutral, and then everything less than 7 here is acidic, and everything more than 7 is basic. And before we talk about pH, we're going to talk about the auto-ionization of water. So water molecules form H3O plus and OH ions all the time by proton transfer. And so notice how, look, we have these two water molecules, and this water molecule gives one proton to this other one and forms H3O plus and HO minus because it gave a proton to another water molecule. And so water automatically does this all the time, and in water, when it does this, it's always equal. So the OHs and H3O plus are always equal, like the concentration. So whenever you see these brackets, that means concentration of H3O plus and then concentration of OH. They're always equal. And they always equal the auto-ionization constant of water, which is K sub W, is always equal to 1.0 times 10 to the negative 14th. So it's always 1 times 10 to the negative 14th. And so this is just scientific notation for a very, very small number. And remember, we just calculate by multiplying the two concentrations. And because they're equal, they're split in half. And so now we have a chart showing H3O plus and OH concentration. So here we talk about auto-ionization of water. So water is always forming these two ions, and they're always equal. So they're always at 1 times 10 to the negative 7th concentration. So we have water here. Then if we look to our left here, we have acids, which have a higher, you know that acids have a higher, or donate protons. So if something is donating protons to the water, what would it have? Would it have H3O plus or OH minus? And the correct answer is it would form H3O plus because we give the hydrogen away to a water and form this. So that's why acids have a higher concentration of H3O plus. So that's why acids have this higher concentration. And whenever we have H3O plus, it's always assumed that there's OH minus. So everything else is OH minus. And then here, if we look to the right, we have the exact opposite. So bases take or accept electrons. So when we accept or protons. So if a base accepts a proton from water, it forms more OH minuses. So that's why bases have a higher OH minuses. And whenever we're talking about pH, there's always OH and H3O. But whichever one's greater tells whether it's basic or acidic. So acids have more H3O plus, bases have less H3O plus, and neutral things have an equal concentration of both of them. And pH, by the way, is just a measurement of H3O plus. And also, the way we calculate, or the way you can tell pH quickly, is just looking by this exponent when it's in 1 times 10 to the blank exponent. So you just take the absolute value of the exponent to see what pH it is. So we'll talk more about that on a few slides down. And this is acidic because it has a higher H3O concentration. So remember, acids are proton donators, so they give more protons to the water. and then bases have less of it because they make water form OHs. So because they have more OHs, they have to have less of this. And so here is the pH scale. So pH is the measure of acidity or basicity by concentration of H3O ions or H3O plus or H plus. So all these mean exactly the same thing. They just mean protons with water. And so this is just a proton, this is a proton with the water, and this has ions. So they all mean the same thing. So as pH goes down, so below 7, like I was saying, there's a higher concentration of H3O plus. So there's more protons to the water. And then we have neutral, which is the equal concentration of H3O and OH, negative. And so it's an equal concentration. And then when we get to the other side, we have less of these H3Os. And so we have a higher pH. And also I would like to point out one thing here. And notice how in these, look at the pHs and look at the concentrations. Notice how the pH has the same number as exponent, but just negative. So pH of 7 has 10 to the negative 7th, 8 has 10 to the negative 8th, 9 has 10 to the negative 9th. So this is going to be very handy when you're calculating pH. So remember, when you're calculating pH, when it's 1 times 10 to the negative 5th or negative 6th, the pH is exactly the same as the exponent. So just remember that when we're calculating. And so notice how all of them, the exponent's just negative of the pH, because they're all just powers of 10. And the formula for pH is negative log of the concentration of H plus or hydronium ions. So you just take negative log of this concentration and you get the pH. But whenever it's 1 times 10 to the blank exponent, you just take the absolute value of the exponent, so pretty much just turn it positive, and you get the pH. But you can only do that when it's 1 times 10 to the blank exponent. And so again, here's the pH scale, and we know that now that acids have lower pHs, bases have higher pHs, and water's neutral because the concentrations of H3O and OH are the same. And then acids have more H3O, and then bases have less of this, so and they have more OHs. And remember, the pH is a balance of H3O and OH. So whenever there's no H3O, there's a lot of OH. Whenever there's OH, there's not a lot of H3O. So it's like a seesaw, you know, you gotta balance it. They're both there, but it depends on how much of H3O there are. And pure water has a pH of 7 because they're both equal. And the reason why is the auto-ionization of water. And because these two are equal, they're both split in half, and they're 1 times 10 to the negative 7th concentration, and 1 times 10 to the negative 7th. So they both have 7 of this and 7 of that. And notice how 1 times 10 to the negative 7th of H plus, and notice how water has a pH of 7. So this is what I'm telling you, that when it's 1 times 10 to the blank exponent, it's always this same exponent. So here pH happens to be 7, and OH happens to be 7 because they're equal. And remember, it always has to equal this constant. This is the auto-ionization constant of water. So that always has to equal this. And remember, in math class, when you ever multiply exponents, you just add them. So that's why negative 7 and negative 7 give you negative 14. So when we divide, we just subtract, and so that's why they're both 7. So just as a side note, but just know that water has a neutral pH because they're both equal, because they both have a 7 as their exponent, negative 7 as their exponent. So here we're going to be calculating pH. So pH is negative log of the concentration of protons or H3O+. So what is the pH of this substance? So remember, when it's 1 times 10 to the negative 7th, or like negative 6 or whatever, the pH is just the absolute value of this exponent. So in this case, the pH would be 7 because we don't even need this formula. We can just look at this exponent and see it's a 7. So this is a pH of 7. And is this acidic or basic? And that is a trick question because it's neutral. It's neither acidic nor basic. So this would be like water. Then we have what is the pH of a solution with a H plus concentration of 1 times 10 to the negative 12? And hint that you don't need a calculator to solve this, because remember, it's in this easy form. When you see 1 and times 10 to the blank exponent, it's just the pH is just the exponent, or the absolute value of it. And so the negative log, if you want to do it, you could type in a calculator and you'll notice that it's a pH of 12. And is this acidic or basic? And this is basic, because the higher pH so has less H plus. Then what is the pH of a solution with the H plus concentration of 0.045? So this one you really need a calculator to solve. And so you take the negative log of 0.045, and if you punch that in your calculator, you would get a pH of 1.35. And if you have a pH of 1.35, is it acidic or basic? And the correct answer is it's acidic. And so here we have a chart. And this shows the H plus concentration, or hydronium concentration. This shows pH. This shows POH, which is just like pH but for hydroxide ions. And then we have OH concentration. And so I want to point out a few things. Notice how pH and POH, what does this add up to? 14. What does this add up to? 1 plus 13 is 14. 2 plus 12 is 14. So you get the point. All of these, the pH and POH always add up to 14. So if pH was 4, you can just subtract 4 from 14 and know that it's 10. And just like H plus and pH are just related, just if it's in this easy form, just by the exponent, the same thing happens with pH. So, POH, sorry. So, notice how the exponent's negative 13, and it's 1 times 10 to the negative 13th, and the POH is 13. And then, same thing all the way down here. We have 1 times 10 to the negative 3, and then we have POH of 3. So it follows the same exact rule, but they're just like opposites. And also, remember, if you multiply H plus concentration and OH concentration, it should equal 1 times 10 to the negative 14. So just like how these add up to 14, the exponent should add up to negative 14. So that's a cool thing. So just remember your magic number, 14. And know that pH, POH always add up to 14. And then if you multiply pH 1 times 10 to the negative 2 with 1 times 10 to the negative 12, you should always get 1 times 10 to the negative 14th. And so here this illustrates that when you multiply these two together, you get 1 times 10 to the negative 14th always. And so we're going to solve for all of these when we have just one thing. So remember, I told you that H plus, it's easy to calculate pH from this when you have in this simple form, and in fact we do. So we have 1 times 10 to negative 9th. And so so what is the pH of this? And this is H plus concentration, so there's no trick. So the pH is 9 because you just get from this exponent. And remember, pH and POH always add up to 14. So if you do 14 minus 9, you will get a pOH of 5 here. And remember, pH, and you know how pH and H plus follow the same rule, that this little 9 just goes for a negative exponent of 1 times 10 to the blank exponent. The same thing happens with here, and so it's 1 times 10 to the negative fifth. So it follows the same exact rule. You just put it with the negative exponent to the 10 and multiply by 1. So same thing here, same thing here. And this is all checked, and you can also double check the concentrations by seeing that if their exponents add up to negative 14, sorry, here. So negative 5 and negative 9 both add up to negative 14. And you can only do this when it's 1 times 10 to the negative 14th. Otherwise, you can just type this in a calculator, so put parentheses on this, and multiply it with this, with parentheses, and you should get 1 times 10 to the negative 14th. And so here we have the opposite, so now we have OH concentration. So it's 1 times 10 to the negative 11th. So let's first figure out H plus. And this is in the simple form, so you can just figure out that the exponents have to add up to negative 14. So if it's negative 11 plus what equals negative 14? And this, in fact, is negative 3. So now that we have the exponent, what do we do with it? So we attach it to the 10 just like this and multiply by 1. So the correct concentration is 1 times 10 to the negative 3. And then once we have this, we can calculate pH very easily because we have a little negative 3 here and it's in a simple form. So pH is definitely 3 because we have in the simple form and the exponent's 3, so the pH is 3. Now we have pOH we have to calculate. We can just calculate from here because we already, we can just use it from OH. Or you can do 14 minus 3 and get 11 also. Or you can just look at this exponent. See, that's 11 or negative 11, so you just make it positive and call it pOH. And also, just as a side note, to calculate H plus and OH, when you multiply them together, you can just always type them in the calculator. And if you have one of them, you can divide 1 times 10 to the negative 14th by the concentration, to get the other concentration. That will work just as well. Or, you can use your math formulas like negative log H plus equals pH, or same thing with H plus and OH. Negative log OH gives you pOH. So they follow exactly the same rules, but they're just like opposites. And so here are some formulas that we've learned, so we learned that pH is negative log H plus, and pOH follows the same exact rule. pOH is negative log of the OH concentration. Then we have the exact opposite. So if we want to go from to H plus concentration equals 10 to negative pH, and then same thing with OH. So it's the same exact thing, but OH numbers. And remember, pH plus pOH is always 14. And if we multiply both the concentrations together, you should always get 1 times 10 to the negative 14th. And remember, when you're just in that simple form with 1 times 10 to the blank exponent, you just add the exponents and see if you get negative 14, and that'll be correct. And also, when you have the simple form, like let's just say this was pH. So if we have this, we can just tell the pH just by looking at the exponent. And so just remember that when you have 1 times 10 to the blank exponent, it's very simple to calculate. You just practically look at this exponent and just do some simple addition. But when you don't, you have to use these formulas. And so here's a diagram relating all the different terms or things, that numbers we have, and relating them to each other. So if you want to convert from H plus to OH, you know how we learned the auto-ionization of water. So practically, when you find OH, it equals 1 times 10 to the negative 14th divided by this concentration, and then exact opposite for the other one to calculate from OH to H plus. Then we have POH to OH and OH back. So remember, POH, you just take 10 to the negative POH of it, and then you get OH concentration. And then negative log of OH gives you POH. Then we have pH to POH. So POH is 14 minus pH. So remember, they both add up to 14. So you can always just work your way backwards and solve algebraically. That's how they derive these. And so, and then same thing with pH. pH is just 14 minus POH. And then H plus and pH just look like this, but with pH and POH instead of pH and H plus instead of pH, POH and OH concentration. So pretty much, notice how they sort of reflect each other. They're just like exact opposites. We just practically just switch these around. And so they pretty much follow a similar rule. But just know that the pH and POH always add up to 14, so you can always just solve from that. Then remember, concentration is just negative 10 to the negative pH or 10 to the negative POH. And then remember, negative log of the concentration is always to pH, and negative log concentration of this is also to POH. And just know that they both multiply to 1 times 10 to the negative 14th. So if you divide 1 times 10 to the negative 14th by the concentration you have, you'll get the other one. And so, quick quiz, which of the following solutions is the most basic? And so if I give you the pHs, it'll be easy to compare. So you can't really do this without pH. And so out of these, remember, the pH scale, the most basic is the highest pH. So which of the following has the highest pH? And the answer is ammonia. And this is a pretty simple question. So just know that basic is higher pH, acidic is lower pH, neutral is 7. H3O, the H3O concentration for the 4 solutions is given below. Which of the following solutions is the most acidic? So here, we can easily convert to pH because we have the simple form. Remember, when it's in the simple form, or 1 times 10 to the blank exponent, we just literally take the absolute value of the exponents and we get literally the pH. But this can only be when it's the H3O concentration, and it is. So this one has a pH of 3, this one has 7, this one has 9, and 14. So which one of the following is most acidic? And as most acidic is lowest pH, so that will be solution A. So the pH of a solution, or what is the pH of a solution with the H plus concentration of 2.5 times 10 to the negative 11th? And this one, remember, when you want to take the shortcut way, it always has to be a 1 out here, times 10 to the blank exponent. But this is 2.5, and sadly 2.5 doesn't work with the shortcut. So we have to actually do the real formula. So if we do negative log of 2.5 times 10 to the negative 11th, I got 10.6, and the correct answer would be B. That matches it. Then we have one more. What is the pH of a solution with the OH concentration of 1.5 times 10 to the negative 3? And before we continue, this one gives you OH concentration. So if we do negative log of the concentration, we will get POH. And from POH, we can go to pH by knowing that if you add pH and POH together, it'll equal 14. So we just subtract POH from 14 and get pH. So that's how I'm going to solve it. Or you could go the other way and know that both their concentrations multiply to 1 times 10 to the negative 14th. And so divide that by the OH concentration, and then take negative log of that, the H plus concentration you just calculated, to get pH. But I'm just going to do the first one. And so I'm going to type in my calculator so to prove that it works. So negative log of OH concentration, which is 1.5 times 10 to the negative third. Okay, so I get a POH of 2.82. So if I subtract that from 14, so 14 minus 2.82, I get 11.18. So that is matched with B. So that is it for today's lesson. So remember pH and POH. So pH is a measure of hydronium or proton concentration, and POH is exact opposite. It's a measure of OH concentration. And so know that the pH scale is based off of pH. No wonder it's called pH scale. And remember that that pH, the auto-ionization of water, so water is automatically forming ions all the time, and they happen to be equal, and they have a concentration of 1 times 10 to the negative 7th, so hence the pH of 7. And remember that little shortcut. So when they give you H plus concentration, and they give you in that simple form, so 1 times 10 to the blank exponent, you just take the absolute value of the exponent or turn it positive, and you get the pH. Bam, and you're done. And then if you don't have that simple form, you have to use your formula. So you have to take negative log of the H concentration. Or if you have POH, remember, POH is like the exact opposite. And you take the you can take the shortcut for that. So it follows the same exact rules. So when it's 1 times 10 to the blank exponent, and it's OH concentration, that'll give you POH. And you can just subtract that from 14 to get your pH. So just know that pH and POH always add up to 14, and know the auto-ionization of water always adds up to 1 times 10 to the negative 14th. And just know your magic number, 14, and you'll be good. And so keep on practicing those problems, and I'm sure you'll get good at it. And if you need any, help, ask your teachers. They'll know how to explain it with paper. I always say, like, math is, you have to have paper to do it, and it's hard to explain it, but I hope you understand it. And then, so the next video is going to be all about titrations, and I'll see you later, and I hope you have a good day.